Hey guys, so I'm not sure how you're going to be watching this if you're listening to this, because you can see right now I'm recording it, so it'll be on YouTube. And I'm also doing the audio recording by recording on Anchor platform. If you're not familiar with the Anchor platform, I highly, highly recommend it. It's anchor.fm. You can create an account, and it's really a simple user interface that is linked into all the popular podcasts platforms that are out there. It could be used for Alexa, can be used for a lot of different things. So, but this is how I'm doing it. So I don't know what method you're watching or listening right now, but thank you for joining us. And my focus today is actually going to be continuing on the DeepComposer thing. So earlier, or the last a couple episodes ago, I was talking about generative adversarial networks, which is a type of AI technology, and the way AWS is one of the ways that AWS is trying to introduce that concept and that technology and that learning platform is through something called DeepComposer. So DeepComposer, if you're watching this, you'll see me doing this, and if you're listening to it, the link to the YouTube will be in the notes. So DeepComposer is it's basically a keyboard, and that you play some notes, and then the machine learning aspect will try to replicate those notes. So is going to predict what those notes are going to be. And there's a whole huge amount of science behind it. I'm not a pro at it by any means, but it's really cool. So if this is something you're wanting to introduce into your classroom, the way that you can do that is through something called AWS Educate. And I've already logged into my account. And with AWS Educate, yourself as an educator or yourself as a student, whichever role you have right now, will have access to $50 of credits with AWS. And this 2 hours and 58 minutes is just reflective of my session time. I have about 3 hours per session time. And then after 3 hours, I just need to relog in if I'm still on it. But I do have $50 credits to play with the AWS platform. And that is one of the advantages of utilizing AWS Educate, is because you get to have the credits to play with it without worrying about running up a bill. So the way you would access is go to AWS console. And what I'm going to do here, you see I'm on the AWS Management Console. And what I'm going to do is search for DeepComposer. Okay. I want to click Get Started. And this is where things can get really fun for your classroom. So you have access. This is all web-based, and you have access to all of this. I actually had a conversation earlier with a colleague asking, with Chromebooks being what so prevalent and what a lot of schools are using, sometimes that Chromebooks is only using Chromebooks can be a barrier for some other platforms. And what's great about this, it's web-based, so Chromebooks will work. So you can click on Get Started. You can start learning about generative AI. And it gives you kind of like a step-by-step, play-by-play on, what it is and how it works. So all you need to do is click on Get Started. And it takes you to Introduction to Machine Learning and Generative AI. So it talks about how everything is pretty much artificial intelligence on this. And then you get to the subsets. So machine learning is part of artificial intelligence. And then within machine learning, you have reinforcement learning, unsupervised learning, and supervised learning. And it talks about machine learning techniques. Machine learning is a subset of artificial intelligence, can help you make better business decisions. Machine learning is a process where machines break down data, learn from it, and then generate a result. So they can use those results to produce something predictive-wise. Deep Racer is one of the AI and machine learning platforms that the AWS created within the past couple of years, and it's still out there. To try to make it fun, and just to introduce the concepts of machine learning, reinforcement learning, unsupervised learning, and all the things that make up AI. And what it does basically, it predicts or creates something based off a subset of data that was inputted. An example of AI that can be used is, try to produce photos of how somebody would look if they were missing 10 years ago. Obviously, the features of a person would have changed over 10 years, and they can use software that are taking the data inputs from an older photo and produce a result, what somebody could look like in the future. Another way for predictive analysts is in regards to, like I mentioned earlier, with DeepRacer. So there's a whole concept of reinforced learning and rewarding. So they want to reward for whenever you're staying on the track as opposed to when you're crashing and going off the track, and that helps produce the results that you want. So, okay, then here it goes into the concept of reinforcement learning. This is the agent, and this model is similar to the DeepRacer. And let's see. Supervised learning. Supervised learning is a technique used to generate a prediction or classification. The goal is to take input data and output data and then train an algorithm to connect those dots between. So as a result, the algorithm learns how to classify or output values from new inputs. And just basically, it's a way to be able to produce results effectively and efficiently using the computing models, as opposed to, where like the human resources and that human talent may be very limited to produce something like this. And then the time, if it's possible, I don't even know if it's possible. I'm sure there's some super genius out there who can do this stuff. But, the possibilities are so much more possible. There's so much more opportunities whenever a computer can do the stuff, as opposed to having to have the human capital to do it. So then there's unsupervised learning. We use unsupervised learning to better understand the distribution of the input data. Instead of connecting the dots to an output variable, we're looking to connect the dots between the input variables. Later, we can use this information to develop a supervised learning-based algorithm. So the generative AI techniques in the DeepComposer, which is the keyboard thing, understand that the underlying pattern distribution in music to generate new music. So I'm not a musician by any length of the imagination, but I understand, like, enough about music. There's only so many notes and there's so many repetitions. I do know that some things are finite. And but with the creativity, the creativity that kind of puts that stuff together. But with that creativity, there's still a rhythm and still a pattern, and they're able to try to understand what those patterns are and connect those dots. So with generative AI, one of the most promising advances of AI in the past decade, which is, like I said, generative AI, opens the door to a world of possibilities for human and computer creativity. There are practical applications for merging across the industries, from turning sketches into images, for accelerated product development, to improving computer-aided design of complex objects. So generative AI enables computers to learn the underlying pattern of a given problem and use this knowledge to generate new content from the input that they receive. That can be images, it can be music, it can be text. Emails are a really great example. I don't know if it's using this specific technology, but there is some technology so that it predicts what I want to say as a response, or auto-completes a sentence that I don't, before I even type it. What it's done is it's captured my personality, so to speak, or it's captured the way I speak. It's captured, it's doing the predictive analysis to save me some typing, in short, and just, make my life a little bit easier, make me think a little less. Let's see. So there's some examples. Let's go back to this last one. There's some examples of how generative AI is used. There's Autodesk, with Airbus is reimagining multiple structural aircraft components. I believe it's an airplane, by utilizing Autodesk. Autodesk is a computer-aided drafting or computer-aided design. I can't recall which one specifically, but it's a tool that's out there that's used a lot for architectural designing, engineering components. So then there's NASA, let's see, and other dental stuff, So there's a lot of great stuff that you can do with artificial intelligence. No matter what, if you're thinking about introducing this to your classroom, no matter what particular realm or pathway or interest your student may have, like we saw, computer-aided design or drafting, I can't remember what that D stands for, to something with dental, to something with NASA, there is a place for AI and machine learning that may not have even thought of before. And this could be a great way to kind of get them exposed to more opportunities if they're trying to figure out how to find their career pathway that they have an interest in. So let's see, the generative AI playground. So talk about human or AI. So a musical composition is an act of creativity that we consider uniquely human. Machines have to learn to recreate the sequential structure of music and be able to choose from a discrete set of possibilities. So music is polyphonic. I don't even know what that means. Several streams of notes played simultaneously on different instruments. I'm assuming that's what polyphonic means. Guitarists might play quicker notes while a pianist holds chords, adding complexity to the machine learning task. Again, I am not musically inclined, so I'm not very good at this music stuff, but there's composition A. Stop that. Composition B. And you're following along, or if you're going to watch this video or going to the website, it's asking, which music composition is AI generated. I have no idea. Generative AI playground. The generative music examples, there are two types of generative AI networks available in DeepComposer. There's UNet and MuseGAN. The UNet architecture was originally created for generating images. The network transforms music into an image-like representation before interpreting it. So basically it turns those musical notes that it's hearing from the audio, it's turning it into a visual format in some capacity. By encoding and decoding a piece of music in this way, the network can learn a general representation of music. So the MuseGAN, I don't even know if I'm saying that right, if the G is supposed to be GAN or JAN, saying MuseGAN. Architecture was built specifically for generating music and the components for each instrument as well as the overall song. It's able to capture the unique characteristics of each instrument and how they harmonize with each other and generate the overall song. So I do know, for the machine learning, for the training aspects of it, there is some use of Bach symphony, I think. And it talks about that in here. Okay. And then there's jazz for MuseGAN. Okay. Generative AI, again, GAN. So generative AI algorithms. Generative AI is a broad category of algorithms, the most popular of which includes generative adversarial networks. And then there's also variation autoencoders and autoregressive models. So again, just kind of like earlier we had, like the big circle was artificial intelligence, and that was machine learning. And within that was the generative AI and some other things. So here within generative AI, we got GANs, we got VAEs, and we got autoregression. So generative AI, GANs. Generative adversarial networks are a type of a machine learning network in which two neural networks compete, which, hence the middle word adversarial. One network is tasked with generative realistic seeming content, which is unsupervised learning, while the other network is tasked with distinguishing the generative content against real data, which is supervised learning. And let's see. So you can see if you're watching or if you're going onto the website that talks about DeepComposer, you can see that there's input and then there's a generator. And then the generator produces output, and then it goes to the discriminator to kind of determine whether or not it is meeting the qualifications or it's meeting I guess meeting the qualifications, meeting the standards that they're looking for. So generative AI GANs, the generator is within a GAN is a machine learning model that's trained to produce realistic seeming output. The generator is like an orchestra. It is trains, practices, and tries to generate polished music. And then, the discriminator is another machine learning model which is trained to take an input and classify it whether or not the input is real or generated. The discriminator is like the conductor. It judges it's like the orchestra's conductor. It judges the quality of the output and then tries to achieve the style of music that has been trained on. The content generation. Initially, the generator produces content samples based on random inputs. And then the classifying content. The discriminator looks for a feature such as the tempo from the data set it was trained on, which can be pop, rock, classical music, in the content samples the generator created. So it decides whether or not the content samples belong to the training set. And then with the training of the GANs, the results of the discriminator's judgments are used to train both models. The generator is trained to optimize for producing realistic content, while the discriminator cannot distinguish from the real. Okay, the generator is trained to optimize for producing realistic content that the discriminator cannot distinguish between the real and from the real samples. Meanwhile, the discriminator is trained to increase its ability to detect generated content. So this back and forth behavior, which is the two parts of the directly competing against each other, is the adversarial part of the GANs. Let's see. So how computers understand music. For machine learning to model to be able to interpret and generate music, it's important to represent music in a format that preserves the precise details of how the music is played. So one of the reasons that I really think this whole DeepComposer and the machine learning and the AI and the generative adversarial networks is super interesting and a really great way to kind of bring into the classroom is it can cover multiple subject matters. If you have kids that are really interested in music, this could be a great way to introduce them to some of the computing things like machine learning and AI using the platform that they already have an interest in, such as music. And music is a great outlet. I love the arts. I am not artistic, but I do love the creativity and appreciate the creativity that comes with it. And for those students who tend to be super analytical and they don't have that much of a creative vibe by nature, myself can be included on that. This could be a great way for them to have some fun and to just kind of flip the switch in their brains and not to be as analytical, but allow the creative juices to kind of flow through a little bit. I know personally, this is something that I try to practice, especially on the weekends. I try to allow myself for something that flips that analytical side of my mind, just so that it can rest. Because I do tend to overthink by nature and it does wear me out. And I need that outlet where it's working on a project here at my house or just, doing something creative. I need that outlet. And this could be a good way for the music being an outlet for someone who has an interest in AI, machine learning, anything computing of that nature, and how, okay, I have an interest in that, but, again, that be the starting platform and then let them have a little bit of creativity with it. So going back into how computers understand music, I think I want to repeat myself a little bit, but for a machine learning model to be able to interpret and generate music, it's important to represent the music in a format that preserves the precise details of how the music is played. So instead of processing the sound file, machine learning models such as those with DeepComposer examine those details to reproduce instruments and musical styles. Let's go ahead and hit next. So I remember learning about pitch in music class when I was in elementary school, and I didn't understand it. So I'm not going to pretend that I know I understand this stuff. But pitch is a tone that is assigned a relative position on a musical scale. Each note is assigned a numeric value starting at 0 for the lowest possible note and ranging up to 127 for the highest. The keys on the AWS DeepComposer keyboard range from 41 to 72. The octave adjust button shifts the pitch volumes up or down in multiples of 12 to play the higher and lower notes. So with the AWS DeepComposer keyboard, it's kind of almost like it resembles a toy keyboard. It's not large at all. And my husband made a joke when he saw it. He said he could probably get one for like $15 at Walmart, where I spent about $100 on Amazon, because it has those little, it's a DeepComposer one. There are some components that a little toy keyboard can't do. But you don't need to spend the $100 on it. With AWS, the platform, you can do it virtually, and which is another added incentive and added bonus of being able to learn techniques and skills like this, and all being on the internet, web based. So even with something as like a Chromebook, students can still do the learning because it's all on the web. So let's see. Click next. Velocity. Velocity encodes how hard a single note is pressed. So pressing the key faster results in a higher value for velocity, which creates a louder sound. Velocity ranges from 1 to 127. Tempo describes how fast music is played. Music typically follows a certain beat or meter, which drives the rhythm of the notes played. The speed of this beat is measured in beats per minute. A higher number of beats per minute corresponds to faster playback. MIDI, I guess, might I? MIDI? MIDI, I'm going with that. File format is an industry standard used by computers to record and store music. The file format encodes details such as playback tempo, which instruments are used in a series of events that encode a note being pressed or released, including the pitch and the velocity of the note. Yeah, no idea what all that stuff means, but there it is. Piano roll visualization. The MIDI format can be particularly represented by using piano roll visualization, which can help you visualize the data. Time is represented on the horizontal dimension, and pitch is represented in the vertical. Bars represent notes being pressed. The start of the bar is the start of the bar is the start of the note being played, and the end of the bar is the note being released. Okay. Let's see. So with DeepComposer, the things that there's the train a model, understand your model, create a composition. Okay. And let's see. So to train your model, you would get hands-on experience by training your own models. Begin to grasp how models work. GANs have two contesting neural networks. One model is generative, the other one is discriminative. The generator attempts to generate data and maps to desired data distribution. Oops. Understand your model. Examine how your generator and discriminator losses change while training. Understand how certain musical metrics change while training. Visualize generated music output for fixed input at every iteration. So this is just like having understanding what it's doing and why it's doing it. What's great about AWS and this platform is that it gives you examples to start with, so you don't have to create something from scratch. But what you can do after you have look at those examples and then you studied it and then you develop an understanding of it, then you can make those tweaks and customize it for your own. The Music Studio. The Music Studio gives you a chance to play music and use GAN. First record melodies or choose default melodies. Then use a pre-trained or a custom model to generate original AI music compositions. Let's see. And then I'm going to be closing up on this particular session, if podcast or video, however you're participating right now. You can explore Music Studio, but let's explore the learning capsules. There we go. And this is going to give you a great introduction to the generative adversarial networks to kind of learn, have a better understanding of what it is and how it works. And that's kind of where we're going to end things. So this is and this is all 100% web-based. So, the barrier of entry for some students who are wanting to learn anything computing-wise is just not having the right type of technology. And this is 100% web-based. So anything like a Chromebook would be work fine with this. And they were able to explore and be curious and to find cool stuff that they really, really like. And I know this is like a lot of information. I've gone through this information probably about 3 or 4, if not more times. And every time I go over it, I have a better understanding of it. The first time I went over it, I'm like, I have no idea what you people are talking about. But the more I go over it, I have a better understanding. Not excelling in it by any means, but I do develop a better understanding of this. So if this is the first time listening to it, explore the platform. Be curious. I try to be as honest with my students as possible. It's like I don't always understand all this stuff, but we're gonna, some of the stuff we're just figuring out together. There's some things that I'm stronger at, and there's some things I'm weaker at. But ultimately, I'm very curious about what I'm learning, and that's what I want to drive home to them, to be curious about what they're learning. So if you have any questions on getting started with a specific platform of DeepComposer or AWS Educate, which is how I access this without having to sign up for an actual AWS account, please let me know and I'll be happy to help. So I'm going to go ahead and stop the video.